when you multiply fractions, you multiply top times top, bottom times bottom. But it makes sense when you can to cross cancel. So if we're multiplying 1/5 times 15 over 7, I can cross cancel 5 and 15 because they have a common factor of what? 5. So 5 can cross cancel with 15, and that leaves me with a 3 here and a 1 here, and then I multiply and I get 3 over 7. Excuse me. So 3/7 is what we would get there. So the same as when we simplify fractions, we can only simplify by canceling common factors. And we can only find common factors by factoring. So when we're dealing with algebraic expressions, we're going to be factoring everything and then canceling any kind of common factors, cross-canceling before we multiply. Now, division of fractions is very similar. How do you divide fractions? You keep the first fraction, you flip the second one, and you change division to multiplication. So you divide fractions by multiplying by the reciprocal of the divisor. So let's have a look at first example. We can definitely cross cancel some things here. And I don't have to worry about factoring these expressions because everything is being multiplied. And here's what we mean by that. The 6 is being multiplied by that, it's being multiplied by that, and that's being multiplied times that, times that, times that. Everything top and bottom is being multiplied. So everything is a factor, so I can cross-cancel anything that I want to cross-cancel. This can get a little confusing, so let's kind of be careful. How do y'all want to do this?
Make the 6 a 2, make the 3 a 1, and make the 7 3 1, and make the 21 3.
Very good. So 3 can cancel with 6 and leave us with a 2 there. Right? 7 cancels with 21 and leaves us with a 3 there. So I canceled a common factor of 3 and a common factor of 7. Let's kind of be careful how we do this. These y squareds can both cancel, right? And x squared cancels with 2 of these and just leaves me with 1x there, right? This y can cancel with that y cubed and leave me with a y squared. And this x cancels with this x to the 4th and leaves me with the x cubed. So when you multiply that, you're left with, up top, 2x cubed. And in the bottom, you're left with 3 y squared x. So we can still multiply, still cancel some things, can't we? I missed an x.
You have 1x on the top, and no, not on the bottom.
No, I'm not going to have 1x on the top. I'm going to have 2. So this will cancel with one of those and leave me with 2x squared over 3y squared. All right? Pretty easy. This is not very unlike the problems that we've already done. It gets more difficult.
You can't cross simplify.
Nothing here will cross cancel, right? So I'm just going to multiply top times top and bottom times bottom.
Now you can reduce.
Can we reduce 18 over 35?
No.
18 is 9 and 2. 3 times 3 times 2, and the bottom is 7 and 5. So no common factors between the top and the bottom, and that one is done.
It's simple.
Yeah, it's pretty simple. Okay, we've already covered that. Here's the next example. Now that last screen said what we said at the outset of the lesson, that if we're going to simplify fractions, we have to cancel or cross-cancel common factors. And to find those factors, we have to factor all the expressions, the numerators and the denominator that can be factored. And this is where factoring quickly becomes a very valuable skill. What can we do with 3x minus 15? Can take a 3 out, and I'm left with x minus 5, correct? And I'm multiplying that times x squared minus 15 minus 2x minus 15. I'm going to write that in fraction form just so I can make sure I see numerator, denominator. What will x squared minus 2x minus 15 factor as? Are you writing this? Come on now.
X minus 5, x plus 3.
Y'all don't be lazy. X minus 5, x
Plus 3.
plus 3 is correct. Over 1.
Well, we already know that one factors can be.
Now everything is a factor, right? The 9 is a factor. The x minus 5 is a factor. The x plus 3 is a factor. The 3 is a factor. The x minus 5 is a factor. The 1. Everything is a factor now. And we can cross cancel things. So I can cancel the x minus 15s. I can cancel the 3 with the 9 and get a 3. And that leaves me with 3 times x plus 3.
Wait, is that the answer?
Over 1? Or will you just be that?
You can put it over 1 if you'd like.
Wait, why is there a 3 there?
Because this 3 in the bottom canceled with 3 in the top.
No, how's there a 3 in the bottom if you simplified 3x minus 5, wouldn't that be just x minus 5? Because you have to take the 3 away.
I did. Where did I take the 3 away from? Canceled with this 9, right?
No, but why is that even there if you already reduced it from 15?
I didn't reduce it. I factored 3x minus 15. You can't change it into something else. So I factored 3 out of that by, like Gray just said, taking out a GCF.
Is the simplified answer 3 times x plus 2?
Yeah. So Chase, are you good with that now? I didn't take the 3 away. You can't just take a 3 away. You can cancel the 3 now. But the purpose of what we're doing here is to factor things so we can see these common factors. So I can see, hey, I've got a common factor there. So those two things can cancel. 3 and 9 have a common factor. 3 goes into 9 3 times. So what I'm left with when I do my canceling, my factoring and my canceling is a 3 times x plus 3 in the top and just a 1 in the bottom. The 1 in the bottom is optional. You don't have to put it. If you put it, it's okay. If you multiply this together, that's also okay. Okay, y'all good? So that's the kind of problems we're going to be looking at in this section. Factoring and cross-canceling, multiplying what's left over. Why can't I cancel anything right now?
You gotta factor it.
Because I have,
They're not all factors.
they're not all factors, right? These two things are terms. I can't cancel, I can't factor terms. I can only cancel factors. So what can I factor out of the numerator on the left? 2m and an n, right? And that's going to leave me with 4m plus 1 over 2m times 15. Can't do anything with 15 yet. What can I take out of the bottom? 6n, and that's going to leave me with 4m plus 1. Now, everything in the numerator is a factor. Everything in the denominator is a factor.
You can take out the 4m plus 1.
I can cancel the 4m plus 1s. See, guys, because we're being multiplied here, and this thing is going to be multiplied times the other one, we can see this as just one big fraction now. Top times top, bottom times bottom. Because everything is being multiplied. Okay? The 4m plus 1s can cancel. 2m's can cancel, right? The n's can cancel. we're just left with 15 over 6. But hey, that can cancel too, right? Can cancel a 3 out of 15 over 6, and I'm left with 5 over 2. Now, who would have guessed that this big, complicated-looking thing is equal to 2.5?
No one.
Yeah, you wouldn't, right? And you can't see that without canceling your common factors. Okay, now let's look at division. We're not going to work through all of these problems. We're just going to switch them to multiplication, and then we'll go from there, especially these easier ones. What do we have to do here?
Key flip change.
Keep the first one. Flip the second one. And change division to multiplication. Now we're ready to do what? Cross cancel, right? We can cross cancel and just to our heart's content and get the correct answer. All right, next example.
Wait,
I am going to finish this one. We're going to finish this one. Because there's something a little bit tricky here you have to be careful with. This second fraction that we're dividing by is 3r minus 4 over 1. I know it's written like on an even plane, but always change everything. If you're dealing with rational expressions, put everything in fraction form so you can see numerator, denominator. And we're going to factor as we go, because I know to simplify this fraction I have to cancel common factors, and to find common factors I have to factor. So what is the GCF or factorization of 9r squared minus 12r? I can take out a 3r, and that will leave me with r minus, no, not r, 3r, thanks. 3r minus 4 over 27. Now I'm dividing, so I'm going to keep the first fraction. I'm going to flip the second fraction and change it to multiplication. And I don't need to factor 3r minus 4 because I can't. And I already have a 3r minus 4 that would cancel, right? So if you see that an unfactored expression can cancel, cancel it. And because the fraction bar is a grouping symbol, this is one thing that we're looking at here.
You can cancel 3r and make it 1 over 27.
We can cancel the 3r minus 4s.
327.
We can cancel 3 and 27.
And then
We're left with
1r.
r over 9.
And that's it.
That's it,
Is that really the entire lesson?
pretty much. Last example. X squared plus 4x plus 3. What's the factorization of x squared plus 4x plus 3? Are there any factors of 3 that add up to be 4?
Yes.
What are the factors of 3 that add to be 4? 1 and 3, right? So this will be x plus 1 times x plus 3 over x squared. Division changes to multiplication, and what do we do with that second fraction? Flip it. So that'll be x over x plus 3. Again, the fraction bar is a grouping symbol, so we can see that as one thing. We can cancel x's. We can cancel this x with one of these. That'll just leave me with x on the bottom.
And you cancel the x plus 3.
We can cancel the x plus 3's, and what are we left with?
X plus 1 over x.
X plus 1 over x is correct. Can you cancel those x's?
Yeah.
No, why not? Because this x is a term, it's not a factor. You cannot cancel terms, you can only cancel things that are being multiplied. So x plus 1 over x is the correct answer. Your homework is that. 17 and 20 are honors problems only.
So we don't do it.
That's correct. If you want a little challenge, you can.
Never. Sorry.
Hey, you guys have a great weekend.
You too. Next one.
Make wise choices.